Hello class, this video covers the first section of chapter 12. Yet we are going to start a new chapter. In the first section of chapter 12, we are going to learn sampling, frequency distributions, and graphs. So some basics about statistics. So let's look at some basic concepts. Data, the first definition, data or data, numerical information such as the information about the top 3 TV shows of the 20th century seen in the table is called data. So data refers to information, numerical information. Numerical information is called data. This definition actually, in fact, not very accurate. It could be qualitative as well. But we follow the book. The book says the data, it could be non-numerical, by the way. But here we refer to numerical information. And statistics. Statistics here is used as a singular, all right? Even it has S at the end of the word, but statistics here is used as a singular. It refers to a branch of mathematics or a method of collecting, organizing, analyzing, and interpreting data, as well as drawing conclusions based on the data. So we have another word, statistic. It's pretty interesting. Statistic without S as a singular, it refers to one piece of data information. For example, if you go to a statistics class, you might learn sample mean, sample proportion, sample standard deviation. So those are statistics, but with S is plural. Yeah, I mean, sample mean is a statistic. Sample proportion is a statistic. Those are statistics. So we have two concepts use the same word. So make it simple. When we talk about statistics, you are taking statistics class, right? And statistics is used as a singular. It refers to a branch of mathematics. It's also a method for collecting, organizing, analyzing, and interpreting data, as well as drawing conclusions based on the data. And statistics as a branch of mathematics can be divided into two main areas, descriptive and inferential. Descriptive statistics is concerned with collecting, organizing, summarizing, and presenting. You do not draw conclusions. But inferential statistics has to do with making generalizations about and drawing conclusions from the data collected. So descriptive is the lower level, inferential is the higher level. Next set of concept, population and sample. Population is a set. The set contains all the people or objects whose properties are to be described and analyzed by the data collector. For example, if you are a researcher, you concern the heights of all the adults in the country. So what's your population? Your population would be all the people live in this country, right? That's your population. Or your population, so you concern the heights of those people. And sample is a subset of a population. Sample is a subset or subgroup of the population. Some sample, when we draw a sample, we want a sample represent the population. In the previous example, if you concern the average height of all the adults in the country, then you want to collect all the heights from all the adults living in this country, right? And then add them up and then divided by the number of those adults, you have the average of the heights of those people. That is called a population mean. Mean means average. But as you can imagine, that task is very time consuming, not practical at all. So in order to proceed with your research, you might consider to draw a sample. And for example, from the 50 states, you randomly select how many people, like 10,000 people, right? And then make a sample of a certain size. And of course, you want a sample to represent the population. When you draw the sample, you want the sample to be random, be representative. You do not want a sample to be a biased sample. When you draw the sample from the population about the heights, you will not just pick those people who play basketball or pick the basketball players, right? If your sample only contain basketball players, probably your sample mean, the average you got, would be higher or overestimate the actual average of the population. So sample here, as it states in this guided note, a sample which is a subset or subgroup of the population is needed. I mean, in order to, if the population is overwhelming, huge size, in this case, it would be appropriate to have a sample of a few thousand TV households to draw conclusions about the population of all TV householders. So population in this example refer to the set containing all the households, all the TV households is a very large population. So population sample is very basic. Very important thing we need to know is sample is a subset of a population. When we draw a sample from population, we want a sample to be representative. We do not want a biased sample. For example, a group of hotel owners in a large city decide to conduct a survey among citizens of the city to discover their opinions about the casino gambling. Part A, describe the population. The population here would be a set containing all the citizens living, all the citizens of the city. Does that make sense? So the population would be all citizens of the city. Part B, one of the hotel owners suggests obtaining a sample by surveying all the people at 6 of the largest nightclubs in the city on a Saturday night. Each person will be asked to express his or her opinion on casino gambling. Does this seem like a good idea? What do you think? This does not seem like a good idea because the sample will be biased, will be a biased sample. Those people, they hung out at one of the largest nightclubs in the city on a Saturday night. They will have pretty strong or stronger opinion about the gambling compared with general citizens of the city, right? So your population is all the citizens of the city, and your sample is supposed to represent the opinions of all the citizens of the city, not just a certain group of players, gambling players. That will be, of course, obviously is biased. And this box gave the definition of a random sample. Very important about a random sample is, in a random sample, every single element has an equal chance to be selected. And this paragraph introduces a way, use a computer to generate random numbers. Introduce a way to generate a random sample. That is one of the random sampling methods. Let's look at this example. We return to the hotel owners in the large city who are interested in how the city's citizens feel about casino gambling. Which of the following would be the most appropriate way to select a random sample? Part A, randomly survey people who live in the oceanfront condos in the city. Part B, survey the first 200 people whose names appear in the city's telephone directory. Part C, randomly select neighborhoods of the city and then randomly survey people within the selected neighborhoods. So after you read all the three options, which one do you think is the most appropriate way to select a random sample? Again, random sample is a sample in which all the elements has the equal chance to be chosen. Part A gives us a biased sample because the subjects in the sample, they are probably very rich, right? They do not represent the general citizen living in the city. So this word, the location where they live, determine the sample is not representative. Part B, survey the first 200 people on the telephone, like yellow book, right? This is a convenient sampling method. Any convenient sampling method will give you a biased sample. It's a lazy way to get a sample. Part C seems a good way, right? In fact, if we modify a little bit, if we divide the whole city citizens, the whole city into communities, and then randomly survey people within each community, then that gives us a stratified sampling. That gives us a stratified sample, and stratified sample is a random sample. So we would choose C for sure, compare with A and B. This paragraph introduces the good feature, introduce the purpose of getting a sample. That's the reason we want a sample representative. And if we have a sample, a bunch of values, right? And we have a name for those. Yeah, we can call, for example, this bunch of numbers, we can call that as a sample or a data set. And each piece of data is called a data item. Let's read this paragraph. Suppose, for example, that researchers are interested in determining the age at which adolescent males show the greatest rate of physical growth. A random sample of 35 10-year-old boys is measured for height and then remeasured each year until they reach 18. The age of maximum yearly growth for each subject is listed below. Okay, so this is a sample. The population would be all the adolescent males, right? The purpose of the research or the survey is to know, to get the data about the age, at which age the boy, the young boy, has the maximum yearly growth. So they survey 35 subjects. So those 35 numbers gives us a sample, okay? And each data is called a data item. And as you can see, we have two 11s here, right? And we see that data item 11 has frequency 2. And we also have how many 12? 1, 2, 3, 4, 5. 5 12s. So the data item 12 has a frequency 5. So that's the definition of frequency. When you look at a bunch of numbers, you probably have no idea what's going on and what kind of conclusion you can draw from the sample, right? So we have ways, we have methods to organize those data. One of the methods is called frequency distribution table. Frequency distribution table. frequency distribution table has two columns. Yeah, I want to probably relate frequency distribution with the probability distribution we learned from the previous section. Frequency distribution table has two columns. The first column, we have the data values listed. Since they are numerical, so we normally list them in the order of increasing, normally increasing order. And the second column lists the frequency for each data item. Okay, so for example, earlier we said 11 appears twice, right? So let me see why it's not letting me to write. Yeah, so we have two boys among the 35 boys has the maximum growth when they were 11-year-old, and we have 5 boys among the 35 boys. They have the maximum growth when they were 12-year-old. Yeah, you can find out the frequency for each item, data item. Sometimes I call the data item entries or elements or values. Yeah, depends on our book, call them data items. Very important thing, all the frequencies in the second column of the frequency distribution table must add up to the sample size. What is the sample size? Sample size is the number of data items in the sample. Yeah, how many numbers in the sample? That's the sample size. In our case, sample size is 35. So the second column, if you fill in all the cells in the second column, all those frequencies supposed to add up to 35. And frequency distribution table has its limitation, because if the sample is very large and the distinct data items are also many, then it will be very troublesome or not convenient to even meaningless to give a frequency distribution like that. So we have another method is called grouped frequency distribution table. Grouped frequency distribution table start from grouping those data. So the process starts from identifying the minimum and maximum values in the data set. So let's look at this sample. Sample size 40. So we have n equals 40. So you see 40 values in this sample, in this data set. And the process of constructing a grouped distribution table, frequency distribution table, starts from identifying the minimum and the maximum. So the minimum is 43, maximum is 94. And then you're going to determine the number of classes. Okay, number of classes. We are constructing grouped frequency distribution table. So you want to determine how many groups do you want. A group simply means classes, right? Yeah, normally reasonable number of classes would be between 5 to 20, depends on the sample size. If the sample size is very large, maybe you would consider 20, right, at the most. If the sample size is quite small, then you do not need 20 groups. In this case, since those values represent test scores, maximum with 100, then it's reasonable to have 6 classes, because the minimum is 43, right? Is in 40s. So we're gonna have 6 groups. The first group is from 40 to 49. Second group is 50 to 59. Third group is 60 to 69, and then 70 to 79, 80 to 89, and 90 to 99. So as you can see, the first class, the first group includes the minimum. 43 is one of the number, and the maximum 94 is also included in the last class. By the way, different people might come up with different group frequency distribution table. If it's me, I might consider those two together as one class, because that's F, right? And this is D, this is C, this is B, this is A. So frequency, a group of frequency distribution could be very subjective. That means different people, different researchers may come up with different grouped frequency distribution table. You think this is convenient, I think the other way is convenient, right? So in our example here, we provide one way to construct the grouped frequency distribution table. We divide all the data items into 6 classes. Yeah, as you see, we have 6 classes here, right? And each class has a minimum value, has a maximum value. They have their own definition. They have their own terminology. For each class, the minimum value is called lower class limit, and the maximum value is called the upper class limit. Yeah, as you can see here, lower class limit, upper class limit. The leftmost number in each class of a grouped frequency distribution is called the lower class limit. The rightmost number in each class is called the upper class limit. And another very important concept is called a class width. Let me explain. When we look at a grouped frequency distribution table, how do we find the class width? How do we find the class width? You will see some of the problem in MATLAB Math. Class width is defined as the distance between any two adjacent lower limits or upper limits. So let's take those two numbers. 40 is the lower limit of the first class. 50 is the lower limit of the second class, right? And the distance between or difference between those two would be the class width. And the class width for any two adjacent classes must remain the same. So this is a 10. Normally remains the same. They are all equal to 10, right? A common mistake is to misunderstand class width as the distance between the difference between the lower limit and the upper limit. If you mistaken that as the class width, you might answer the class width equals 9, but which is incorrect. That is incorrect. Again, class width is the difference between any two consecutive lower class limits or upper class limits, right? Okay, so the grouped frequency distribution has those classes as the first column. And then the second column, we don't really have this column as a part of the grouped frequency distribution table. Yeah, they also have only 2 columns. And the second column would be the frequency, or the number of students whose scores fall in each class. One way to do that is the tally method. You will expect to have problems like that on test 3. I see students copy the whole sample on the scratch paper and then work on the paper. That's one way, right? Because if you only look at the screen and the words is so tiny, it's very easy to make a mistake. And I also see students do this. They use one hand to point the numbers, go through all the numbers, and the other hand to do the tally. For example, we want to know how many students fall in the first class, right? What's the frequency of the first class? The first class has a lower limit of 40, upper limit of 49. Then I would point my finger, my left hand finger, I'll point at the numbers. I would go through each number by row or by column, depends on your preference. And then I'm going to mark those numbers that fall between 40 and 49, including 40 and 49. All right, so I have this one, I see this one first, right? Yeah, I do by row and nothing else. Second row, I'm looking for number between 40 and 49, right? I don't see any. Third row, I do not see any. Row number 4, I have 45, also 43, right? Two numbers fall in the first class. And the last column, last row, I do not see any. So the frequency of the first class would be 3. Does that make sense? You can use the same method to complete the second column and double check the numbers, all the frequencies in the second column should add up to what? Should add up to 40. Because that's the way how do we construct the grouped frequency distribution table, right? As you can see, there's no gap between each class. There's no gap because we do not have decimals, right? Yeah, so all those classes include all the 40 data items. And then you complete the frequency group the frequency distribution table. A disadvantage of grouped frequency distribution table is you would not see the original raw data anymore. This one, frequency distribution table, has the raw data, right? You know exactly how many 11s, exactly how many 12s, and what are those values, raw data are in this table. But grouped frequency distribution table will not show you the raw data anymore. You would not know. All you know is classes and how many values fall in each class. Depends on what you need. Depends on your research. Choose the correct table. This table is the frequency distribution table for the example that we saw earlier. We have 35 boys and we collect their data about which year, at what age they have the maximum growth, right? So yeah, that's the example. So this is the frequency distribution table. Frequency distribution table is one way to display or organize the data. Another way to organize the data is the histogram. And histogram simply is a graphical translation of the frequency distribution table. Yeah, this graph is a histogram. Histogram is a very important graph in statistics. So it's a two-dimensional graph. Horizontal scale is the first column, age of maximum growth, right? 10, 11, 12, all the way to 18. And vertical scale describes the second column. So the vertical scale is the frequency. So you will see in a histogram, you will see many bars, and those bars are equal width, and those bars attach to each other. There's no gap between those bars. If you see bars with gap between, then that's not a histogram. That's a bar graph. It's two types of different graphs. So in a histogram, all the bars must attach to each other. And the height, very important, the height of each bar is the frequency for each value. As you can see, for example, among the 35 subjects, we have seven kids. They had their maximum growth when they were 13-year-old. Does that make sense? So the height of the bar is the frequency of each value. So that's how do we understand histogram. As you can see, histogram directly translates frequency distribution table. Horizontal scale is the first column. Vertical scale is the frequency column. And we have here, it pointed out, because the jagged line here indicating that we do not start from 0. That eliminates listing the ages from 1 to 9. We start from 10. And another way to organize or display or graphically describe a data set is polygon, frequency polygon. And we can get a frequency polygon directly from the histogram. This is the histogram we see earlier, right? And if we find the midpoint of each bar on the top of each bar, like that. Why is the midpoint? Because that corresponds to 10, right? The value. Yeah. And then connect the line segment between any two consecutive dots, and then we will have the frequency polygon. Knowing that you must have this part touch the x-axis, but do not have a dot there. And also here you have the line touch the x-axis as well, but you do not have a dot there. The number of dots represent the number of distinct values in the first column. There's a meaning for that. So both histogram and frequency polygon are graphical way to organize a data set. And what's the benefit? Benefit is you can see the trend, right? You can see the distribution. Yeah, why do we call the frequency distribution? And you can see majority of the kids had their maximum growth at a 14-year-old, right? Yeah. You can see the distribution. Less kids maximum growth happen at 10, 11, 12, at the 10 or 11, or 18 probably too late. Majority kids, they have their maximum growth at 13 or 14 or 15. So you can see the distribution. And besides histogram, distribution, polygon, in this section we introduce another type of graph. It's called a stem and leaf plot. Stem and leaf plot. As you can see from the name of the plot, we have two parts. We have two parts from the graph. The example we have here is a data set containing 40 students' score, right? And since they are scores, they are all of the 40 scores are two-digit numbers. And in that case, we use the stem to represent the 10th digit, and we use the leaf to represent the 1st digit. Yeah, so once I start to construct the stem leaf plot for this given data set, you would understand how does a stem and a leaf plot work. All right, let's start it. So we decide, because all the values are two-digit numbers, so we use the stem to represent the 10th, the first digit, and use the leaf to represent the second digit, the ones. It's not always like that. Depends on what kind of values you have. Depends on what kind of data items you have. Some people, if the data are decimals, they use the stem to represent the whole number part and use the leaf to represent the fractional part. It really depends on your values. It has the subjective factor. Then how do you make the decision? Okay, remember the minimum is 43, maximum is 94, right? So I'm gonna start from 40s. Yeah, stem is 4, and the minimum value is 43. Do we have 44? No. Do we have 45? Yes. So I have 5 here. Do we have 46? No. Do we have 47? Yes. So I remember we only have 3 numbers in the first class, right? So 7 here. Do you see that? So that's the first row of the stem leaf plot. I give you actually literally give you the first class 43. Yeah, you have 143, you have 145, you have 147. Yeah, that's one advantage of this plot, this type of plot, because it reverses the raw data. Yeah, let's try again. Okay, so firstly, I'm going to find out all the 50s. So let's see how many numbers go from 50 to 59. The first column, I have this. Second column, I have this number. Third column, no. Fourth column, 56. And the last column, 57, 50, 59, right? So the second row of the stem and leaf plot, I would start from 5, right? It's 50-ish. So the leaves are gonna go from smallest to the biggest, follow the increasing order. So I have 50, 0. So I have 0, 5, 0, 50. Do I have 51? No. Do I have 52? No. 53? No. 54? Yes, 154. Do I have 55? No. Do I have 56? Yes. How many 56 do I have? 1. So 1, 6 here. And then do we have 57? Yes. How many 57s do we have? 2 57s. So we're going to write 2 7s here. Do you see that? Write 2 7s there because you have 2 57s. Do we have a 58? No. Do we have 59? Yes. So as we can see, we have a 1, 2, 3, 4, 5, 6. 6 numbers fall in the second class, right? So you should have 6 digits in the second column, the leaf part. And when you look at the second row, you know, okay, among the 40 numbers, I have 150, I have 154. Yeah, one student get a 56, 2 students get a 57, 1 student get a 59. Yeah, I would let you to finish the rest of the stem leaf. The last one would be 90-ish, right? Yeah. As you can see here, an advantage of the stem and leaf plot over the histogram is that the stem and leaf plot preserves the exact data items. You can see the raw data from the stem leaf plot. Even better, once you finish the whole graph, you also see the distribution. You will also see the distribution. Yeah, whatever distribution, you can see that. Just turn your head 90 degree. Turn your head 90 degree. You will see the distribution that way. And the last topic of this section is about deception of graphs. Yeah, how do we identify deceptive graphs? One example we have from the guided note is those 2 graphs. And both of the 2 graphs are drawn, come from, or based on this table. Okay, yeah, let's look at the information in the table. First column are years, 2015 all the way to 2019. And the second column is each year's poverty rate. As you can see, the trend is decreasing, right? The poverty rate decreasing, so it's a good thing. And the graph on the left is deceptive. Why is it deceptive? Because it stretched the vertical scale to make the decreasing more dramatic. And the graph on the right is also deceptive. Why is it deceptive? Because it compressed the vertical scale to make the decreasing trend a lot milder. So if you if you are the current, let's say, president or mayor, and your debate opponent is the person wants to replace you, right? And probably your team would choose this graph, and your opponent will choose this graph, right? Because you would exaggerate the good thing. The poverty rate is decreasing since I was in office, right? Then your opponent, they want to downplay the fact, so they would compress the vertical scales. Yeah, that's just one way to create deceptive graphs. Or when you work on the MATLAB math, you'll see a few more examples. It's kind of interesting, and you see that a lot in politics, political field. And the last table here gives us things to watch for in visual displays of data. So just go through those things briefly. Number one, you're gonna look for, is there a title that explains what is being displayed? You have to make it clear, right? X-axis, Y-axis. Number two, consider axis fraud. Are numbers lined up with tick marks on the vertical axis that clearly indicate the scale? Has the scale been varied to create a more or less dramatic impression than shown by the actual data? So our example above shows the dramatic impression, right? Number three, do too many design and cosmetic effects draw attention from or distort the data? Number four, has the wrong impression been created about how the data are changing because equally spaced time intervals are not used on the horizontal axis? Furthermore, has a time interval been chosen that allows the data to be interpreted in various ways? Number five, are bar sizes scaled proportionally in terms of the data they represent? Six, is there a source that indicates where the data in the display came from? Do the data come from an entire population or a sample? That's a very good one. Was a random sample used, and if so, are there possible differences between what is displayed in the graph and what is occurring in the entire population? Who is presenting the visual display, and does that person have a special case to make for or against the trend shown by the graph? This is one way to practice critical thinking. All right, so that's the end of the note. I hope you learn the basics after watch the video. Knowing those basic concepts, also know what is frequency distribution table, what is a grouped frequency distribution table, what does a histogram look like, horizontal scale, vertical scale, what does a frequency polygon graph look like? Yeah, how do we construct stem leaf plot for a given data set, and those things, and also how do we identify deceptive graphs? So if you have further questions, please feel free to email me, and I'll see you in the next video.